Okay, ladies and gentlemen, we are on 6.5, which is page 18 in your notebooks. We're going to find an equation for a line given the slope and a point. We're going to just take a few notes before we do that. Here we go. The slope of a line gives its direction. The slope of a line gives its direction. For any given slope value, there are many possible lines. So there are many different lines that have the same slope. So for example, if you have a little bit of off to the right, just draw a quick little coordinate plane and just draw a few lines that all have the same slope. Now what's true about those lines? They're parallel to each other. Okay? So let's say this is a family of lines that has the slope kind of looks like 2 over 3 or something like that. Okay? So this is a family of lines. Shown is a family of lines, period. They all have the same slope. Alright. Suppose you know that a line has a slope of 1/2 and it goes through the point 1, 5. So think about that and don't call anything out loud. But let's say you know that a line has the slope of 1/2 and it goes through 1, 5. How many lines do this? Don't call it out. How many different lines do this? How many different lines have a slope of 1/2 and go through the point 1, 5? Put your thumb up on your desk if you think you have an answer. Sandy, what do you think?
Only one.
Jenna, what do you think?
1.
Jada, what do you think?
1.
Maddie, what do you think?
1.
You guys have nailed it. If you know the slope, that doesn't tell you the exact line. But if you know the slope and a point that it goes through, there's only one line in the whole world. So for instance, if we were looking at, say, this point, this is the only line in the whole world that has this slope and goes through this point. That's it, right? If we had the same slope and we moved it over, it would no longer go through that point. If we went through that point but changed the slope, it would no longer be the same line as well. Okay? So we're going to find the line that goes through a specific point and has a specific slope today. Okay? Let's look down at example 1. It says find the equation of a line with a slope of 1/2 that passes through 1, 5, and then graph that line. What do you think we're going to do? Well, we're going to start with our equation, y equals mx plus b. Now our goal when we're developing an equation is to have it in this form, and we're going to replace m with a number, and we're going to replace b with a number. Okay? Now what do we already know? We already know that m equals, here I'll put a little note here actually, sub m equals 1/2. Alright, so here we go. We've got y equals 1/2 x plus b. Now, do I know what b is?
No.
Yes.
No.
Yes.
You don't.
The
Yes, you
y-intercept.
do. It tells you
B is the y-intercept. Do they give me the y-intercept?
Yeah.
Yes.
No.
Oh.
The y-intercept is the value of y when x is 0. I don't have that. I have the value of y when x is 1, right? So I actually don't have the y-intercept, but I do have, and let's make a little note here, the point 1, 5 satisfies the equation because it is on the line. Now, this is a concept that you really need to remember for the rest of your mathing careers. The line is satisfies the equation. Satisfies the equation means that I could put the point 1, 5 in this equation and it would come out true. Okay? Now just watch and we'll kind of develop our understanding as we go. So here's what I'm going to do. I'm going to sub x equals 1 and y equals 5 into the equation. So here we go. I know that when x is 1, y will be 5 on this line. Okay, so normally we leave y and x alone. There are dependent and independent variables. But in this case, I know for certain that one of the matches between x and y is 1 and 5. And watch what happens when I sub those in. So 5 for y, 1 for x, plus b. What happened to my equation?
You can figure it out.
Now I can solve for b, because there's only one variable left. Let's make a little note of that. Now, since b is the only unknown left, I can solve for b. Now what's cool about this is that we know x and y are going to change dependent on each other, right? So this is one point that's on the line, but there's actually an infinite number of points on the line, infinite number of x's and y's. But all of them will have the same y-intercept. The equation will always have the same y-intercept. So if I use this point to find out what b is, then that b is going to stay that value always. Okay, so watch what happens. We've got 5 equals 1/2 times 1 is just 1/2 plus b. And now to get b by itself, I can subtract 1/2 from both sides. So I've got 5 minus 1/2 equals b. And I'm just going to flip that around. b equals, and I'm going to leave it as 4.5. But it can also be 9/2. Now that's the y-intercept. Well, if that's the y-intercept of the line, then it's always going to be the y-intercept of that specific line. That line will always, only ever go through the y-axis at the point 4.5. Okay? So now what we do is we sub b equals 9/2 into our equation, and put x and y back in. So our equation is always in the form y equals mx plus b, where m is the slope, b is the y-intercept, and x and y are the variables. X is the independent variable, y depends on x. So when we're all said and done, we've got y equals 1/2 x plus 9/2. This is the equation of the line that has a slope of 1/2 and goes through the point 1, 5.
Wait, but I thought B has to go through 0.
All right, time to graph this line. So I'm going to just erase some of my notes so that I have some more space. And here we go. You have a coordinate plane drawn in your notes already. Looks kind of like this. You can label your x-axis and your y-axis. And whenever we're graphing a line in y equals mx plus b, the easiest way to do it is to find the y-intercept. So what's the y-intercept? 4.5. So let's go 1, 2, 3, 4, 5, and I'm right here.
Can't you use your other point that they gave you?
We could also, to draw it, we could use the other point that they gave us. Good thinking. So we could actually use 1, 5, which is about right there, and then draw it. What's another way that we could draw it?
We could find this slope by
Do we have to find the slope?
right.
No,
You have
we
to
have
go
to-
like
We already have the
No, I
slope.
mean,
down
you use
across
So we
one
can
and
use
down
the slope. Rise over run.
Rise 1,
So
2,
up
across.
1 over 2. Up 1 over 2. Grab your straight edge. Grab your ruler. Draw a beauty line. Arrows on each end. Then are we done? What do I have to do? I have to label my line. Y equals 1/2 x plus 9 over 2. Or y equals 0.5 x plus 4.5. Okay. Now when you're doing this on your own, you simply need to look back to this example and say, what did we do? I do the same. Read through that block of notes that you have on the right side. Okay? We did it this way. You do it the same way. Example 2. Gina knows that it costs $25 to take a taxi to work, which is 10 kilometers from her home. Okay? She forgets what the fixed cost is, but remembers that the variable cost is $2 per kilometer. Next, her friend lives 12 kilometers away from Gina's home. Gina has $60 to spend on the weekend. Can she afford a round trip to see her friend? So there's quite a bit going on here. The first thing that we're going to do, and your questions aren't labeled there, so go ahead and write A. Find the fixed cost find the fixed cost and write an equation to model the situation.
Or you can just go to the plus $2.50.
Find the fixed cost, write an equation to model the situation. So what we're going to do is find the fixed cost. So we're already told that this is partial variation. So I'm just going to jot, we know this is partial variation. What does that mean again?
Doesn't cross through the origin.
It does not cross through the origin. So in a practical way, what does this mean about the situation with the taxi cab?
It's automatically has a set cost.
Good. It has a fixed cost. As soon as you jump in the cab, it's going to cost you so much, and a variable cost that depends on the distance driven. Now, she doesn't remember the set cost, so we're going to help her find it out, okay? We know the variable cost. Keep just jotting down things we know, right? The variable cost is what? $2 per kilometer.
That's no small thing.
Okay, now thinking in the form of an equation of a line, what does this variable cost tell us? what part of the line, what part of the equation is this?
That is the distance.
That's B.
No, B is the initial cost.
No, that's X.
This is the constant of variation, right? So what we have here is m, and we still need to find b. We don't have b. Okay?
So M is slope, but also variable cost.
Yes. Yes, always. It's the constant of variation. Yep, since the beginning. Okay? Now, we are trying to find the fixed cost, but I don't know what the fixed cost is. But do I have other information that might be able to help me?
U minus
12 kilometers.
2.
I have the how much it costs for her to get to work, and I have the distance of work. So let's make another little note here. Basically, this situation, guys, is going to create a graph that is distance and cost. Right?
Okay.
She's going to pay based on the distance that she travels. It's going to be a straight line with a slope of 2, and we're trying to find this point right here.
It's $2.50.
Do we already know another point on the graph?
Yeah, the ending.
Yes.
We know
10.
we know the coordinates of when she gets to work, right? How far does she travel for work? 10 kilometers. So our horizontal coordinate is 10. How much does it cost her?
25.
$25. Okay? So we actually know this as well. So what can we do with that information? Well, if I rewrite my equation relating cost to my slope, or my k, constant of variation, times x plus, I guess this is d actually, right?
Did we do this before?
Yep, we've done stuff like this before. And this is my initial value b. Now we already know that the slope is 2, but we also know that the point 1025 satisfies the equation. Okay, so let's write what we did. We sub m equals 2. And now we're going to sub in 1025 to find b. Alright? So d is 10.
Where'd you get 2 from?
That's the slope, $2 per kilometer, the variable cost. We don't know b, and when d is 10, c is 25. Now we're going to solve for
B.
b.
Did we have to get B by itself?
Yep. What's 2 times 10?
20.
What do I do next?
Minus.
Subtract 20 from both sides.
Yes.
25 minus 20 is
5.
5.
5 equals B.
$5.
Okay? So what is
What is it?
what is the fixed cost?
It's constant.
What's the fixed cost?
$5.
$5, and she's getting charged $2 per kilometer. So now we need to actually finish our equation. Therefore, C equals 2 times D plus 5.
Can Maddie show her easier way?
Okay?
This is common sense. You 2 times 5 minus 25, because it's $2 times 10 kilometers minus the 25.
Well, you guys can do it on a really easy problem. Way to go. Right? It's not always going to be this simple.
I know, but it's just
Okay?
this one.
So
was
here we
common
go.
sense.
Try it on a harder problem.
Let's
Yeah,
draw.
I know. I'm just saying this one is common sense.
Okay, here we go. Let's draw our graph of our line. So we have distance at the bottom, horizontal axis. We have a cost in the vertical axis. Okay, the maximum cost we're kind of talking about is
$60.
Because she has.
Yeah, sure. Let's draw a big graph. Then we'll go all the way up to, well, it's a round trip. So for one way, let's go up to about 30. Okay, split that. However you need to do it on your graph. And the distance driven is going to go up to about 15 kilometers. Yeah, we're just calculating one way here. This is measured in kilometers. This is measured in cash money. And now we can graph our line. We know that the fixed cost, the y-intercept, is 5. And we know it's going to go up a slope of 2. Or we know it's going to go through 1025. Either way.
Wait, would it be 2 over 1?
Yep, it'd be up 2 over 1, up 2 over 1, or up 10 over 5. Right?
Oh.
Be careful, don't use your blocks. Don't go up 2 blocks over 1 block, because your scale is not equal on the horizontal and vertical axes.
Can we draw that line now?
You can draw that line.
What if you do your graph different than the lines change? Does that matter?
Nope. Not at all. As long as you label your line. Okay, this is the line C equals 2D plus 5. So that's B. Graph it. Now in C, we want to answer the final question. We want to find out if she can afford the round trip to go to her friend's house. Okay, her friend lives 12 kilometers away. Can she afford it? So there's 2 ways to do that. One way, which is not recommended, is to say, okay, 12 kilometers is right around there, and we look at our graph, and we say, is that still less than $30?
Yes.
Yes.
Just less than $30. Okay, so by looking at the graph, if we have a perfect graph, we can say, yes, she can afford that.
So how does
Right?
it
If she can go one way for less than 30, then she can go both ways for less than 60. Okay? The algebraic way to do that, so C, can she afford the trip to her friend's house? The algebraic way to be that would say, okay, if we're trying to find the cost of going 12 kilometers. So all we need to do is sub in D equals 12. So where we have 2D plus 5, we're going to sub in D equals 12
2 times
Oh, yeah.
to see if she can afford it. Well, 2 times 12 is 24.
It's 29.
Plus
Oh,
5
she adds it.
equals 29. Can she afford it?
Yes. She'll have $1.
Therefore, Gina can afford
$9.
the round trip
She just buy a bike and get some like that.
to her friends.
For $60.
You can find one.
In the dump. Pick it up. We'll pick it up.
Okay, just as a quick review for this next section, what are parallel lines?
Lines are
and they will never
Same
touch.
slope.
Same slope, and they will never meet.
Lines that
Same
go
slope.
the same
Perpendicular lines?
They will
Cross
cross
at
at
a
90
90
degree angle.
or
Okay,
the
what's true about their
intersect
slope?
At right
They will-
angles.
Opposite. Negative.
Negative slope.
Negative reciprocal
Negative reciprocal, yeah.
slopes. Okay, example, if M1 is 4 over 3, what's M2? Negative 3 over 4. Okay, someone else? If M1 is
Negative 1.
negative 2, what's M2?
Positive
Top
1/3.
2.
Positive 1/2. Okay? Good. We need that information going forward. Here we go. Example 3. Find equations of lines parallel or perpendicular to the given line. So here we go. Find the equation of the line that is parallel to x minus y minus 12 equals 0. And there's a note missing there for you. You need to be passing through. Add this to the end of that example. Passing through the point 2, negative 5. Okay, so it's got x minus y minus 12 equals 0.
If you give us the coordinates, why don't we just graph it?
You have the coordinates of one point on the line.
Yeah, we have to know the slope.
Then you
So we
have
just
to
need
put
the
this in
slope.
Y equals mx plus b4.
So good. We need to convert first. Convert our equation to y equals mx plus b. So I'm going to copy down the equation here. X minus y minus 12 equals 0. And then I'm going to say first convert to slope intercept form to determine the slope, comma, m. So first convert into slope intercept form to determine the slope. Jacob, what am I going to do in order to convert this into slope intercept form?
Get y by itself.
I want to get y by itself. Can you give us our...
Y equals mx plus.
To get it in y equals mx plus b. Nice. So what am I actually going to do? What's my next line look like?
We could, add y and then just add y to the 0.
Sounds good. I'm going to add y to both sides. It's going to leave me with x minus 12 equals y. And then I'm just going to rewrite that. Y equals x minus 12. Are we in mx plus b form?
Yes.
Okay. What is the slope of this line?
Do we technically need it because
Good.
we have the
How do
y
we know that?
intercept?
Oh, yeah.
Because x has
Yeah,
different
So m1 equals 1. So the slope of my first line equals 1. So what's the slope? Remember, I'm looking for a line that is parallel. So what's the slope of my next line going to be?
Negative y.
No, that would
Parallel.
parallel line.
be 2. No. Negative 1.
No,
Yo.
one, just one.
Mr.
Nope.
I have
It's the
something.
same.
Because don't you gotta do the
Since you have the y,
Parallel.
since you have b,
Parallel.
One,
Just
one.
one.
It's going to be
Same slope, folks.
since you already
Same
have
slope for a
b,
parallel line.
It's not perpendicular.
Okay, good.
I know.
So we know that the slope of our second line is going to go through this point. The first line does not go through this point. I'm not asked to graph any lines. I'm asked for the equation of a line that has the parallel to this line and goes through this point. So now when we're talking about our second line, we know m equals 1. So sub m equals 1 and the point 2, negative 5 into y equals mx plus b. Alright, so here's what that looks like. For our second line, the line that's parallel to the first line, we know that the slope is 1, and we know that it passes through 2, negative 5. So I sub negative 5 in for y, and I sub 2 in for x. Just like last time, we know that that point, those coordinates, satisfy the equation. So now, because I know this is going to be true, I solve for b. Negative
So
5
what's the
equals
brackets? I can't
2
see
plus
that.
b.
Is that 2?
To 2, yep. Negative 5 equals 2 plus b. Subtract 2 from both sides. I end up with negative 7 equals b. And Now sub m and b into y equals mx plus b. And then we're done. Y equals, the slope is 1, which I can just leave out. So y equals x minus 7.
That's it.
That line is parallel to this line, and this line goes through 2, -5. I could double check that it goes through 2, -5 by subbing in 2, -5
Could you just subtract
into our points.
5?
Okay? And that would tell us that this is indeed a true statement. Okay?
Could you just subtract 5 and 2?
In B, we are looking for a line that is perpendicular to the line y equals 4x plus 5. It passes through the origin. So they've helped us out in this one. Why is this one, why is the equation a little bit easier to work with?
Because we have m.
It's already in y equals mx plus b form, which means they've essentially given us the slope. So what is the slope of the first line? What's the slope of the line that they gave us? 4. So what's going to be the slope of my second line that's perpendicular to that line?
Negative 1 over 4.
Okay, Sam, you understand that?
Yeah.
Okay, negative reciprocal is perpendicular. Okay, so what I could do in my next step is I could simply sub my slope in. So now I have y equals negative 1/4 x plus b. What other information have they given me to help me out?
It passes through the origin, which means B is 0.
The y
Ah.
plus 5.
B equals 0 since the line passes through the origin. So, sub in b equals 0. Y equals negative 1/4 x plus 0 reduces to y equals negative 1/4 x. This is the equation of a line that is perpendicular to this line and passes through 0, 0.
So that's the only line in the world that does
The only line in the whole world that does that. Good. Your practice problems are on the following page.
See those key concepts.
Do each one very, very carefully. And here come the key concepts. For page 20 at the bottom, you can find the equation of a line if you know its slope and one
property.
point on the line. Okay, a set of coordinates. You need both coordinates. You need the x coordinate and the y coordinate. Right? So that's a point. Okay? You can find the equation of a line if you know its slope and one point on the line, and keep reading through at the bottom. It's basically your step-by-steps on how to do it. First, substitute the given slope for m and the coordinates of the given point into the equation to solve for b. Then, write the equation by substituting m and b into y equals mx plus b. Same steps over and over and over again. You guys got this.